Hello, one and all. This is Coach Jay with my Influence Cup. I might just take this to San Francisco with me. Hope you like this as your graduation gift. That's what you're going to get. You're going to get this. But gotta love it. Gotta love our Inference Cup. And gotta love statistics. This is section 5.1b. Coming off of 5.1a. I hope you liked yesterday my free throws. Gotta love it there. We're gonna get right straight into it, and I want to give you the scenario and let you know kind of what happened. So one of the things we did as kids, this is a 2-liter, but a lot of times we would get the smaller versions of this. Is it like a half-liter or something? I don't know, fluid ounces or whatever. But one of the cool things they used to do, and I know they kind of changed it now, but they used to on the caps had these things that said, maybe not a code. Now they have like codes, right? I've never done these, but we used to have things like on Sprite or on Cokes where we wanted to see whether we actually won something. And it would actually say on the cap, hey, you won, or you didn't win, try again, or whatever that may be. Well, there's this scenario I want to show you. Now I'll kind of point you to this direction here as we turn down our tunes here. And the scenario was back in the day with Sprite. Sprite's my favorite. I love me some Sprite. But basically, it says Pepsi. Again, I'm a Sprite guy. But they were in a contest where these 20 ounces, that's what it was, 20 ounces. I would say, hey, 1 in 6 win, right? So 1 of 6. And so basically, we would expect 2 of the 30 students get caps that say, hey, you're winners, right? So that was we were trying to see if that is true. So we're going to wonder, is the claim actually true? Now, to find out, we're going to have all 30 students in the class. We're going to go to the store. We're going to all buy one 20-ounce bottle of soda. 2 of these 30 get caps that say you're a winner, okay? And so 2 of the 30, okay? So here's this, right? 2 of the 30, we're going to say, and really, I never did 30 in that way, but what I would do is I would go to the store and get all of these Sprites and then take the things off, the tops off, and say, hey, was I a winner, yes or no? And based upon that, I'm going to try to see, is the claim, do we have convincing evidence to say that the claim is actually false? And that's what we're going to look at today. So the first thing we're going to make sure we look at is this screen. This screen, we're going to use the dice roll simulation. And if you want to, you could actually scan that in the top right corner. And then you could also go to this link at the bottom too. You could also type that in as well. But that QR code, I believe, will work on your phone as well. All right, so let's look at this. How many winners would you expect to get out of a class of 30? Now, what did we get? We got 2 out of 30. But if they say that there's a 1 in 6 chance, that means that every 6, you should get 1 of 6 based upon what they said, which would allow us to expect 5 out of 30 students would get a prize, right? Ours used to be like free t-shirts or something, right? Would receive a prize. All right, perfect. Now, does this guarantee that 5 of 30 will get it? No, it actually could be more. It also could be less, right? Because again, remember, 1 in 6 times 30 would get us to 5 of 30 or 5 total, right? Is what we would expect. But remember, this is not guaranteed. That's something that's very important, okay? It's not guaranteed. Now, does this provide convincing evidence that the company's 1 in 6 claim is inaccurate? Well, we assume Pepsi is telling the truth, okay? We have to, because you're innocent till proven guilty. That's how we operate in statistics as well. So is there convincing evidence to say that they are in fact telling a lie? So we're going to find out. Let's try to mimic this up a little bit and try to simulate this. So we're going to do a little simulation. So what could we use to model 1 in 6 probability? I want you, wherever you're at right now, I want you to yell it out. And you would be right. It is a dice, okay? Dice, because it has equal probability. And that's really what we're trying to get within the simulation is something that has equal probability. All right. Now, what would represent a winner? What would represent a loser? Well, one, we're going to say you could do this different ways, but I'm going to say a number 1 is a winner, and a number 2 through 6, that's going to be the loser based upon what the claim is of the company. So this is the claim of the company. All right, so here's what we're going to do. We're going to roll this dice 30 times to imitate the process of students actually getting a Sprite and seeing whether their soda won or not. We're going to see how many won prizes. So here we go. We're going to go backwards here. And I want to go to, I'm going to knock this off, come back here. Hello there. All right, let's go here. Perfect. Okay, so we're going to simulate this. This was from what we were doing earlier, or the little QR code. This is what it should bring you to. Okay, so we're going to simulate this. And here we go. We're going to go 1, 2, 3. Wow. Okay, so actually 5 winners on this one. So we're going to kind of just record this. So, and I'm going to record this on mine. You can record it on yours. So if I rolled my dice 30 times to imitate the process of students buying their soda, how many of them won? 5 won for me. And I want to repeat this at least one more time. Now, for me, what I'd like to do is actually repeat this a bunch of times. So I'm going to, you want a pencil and paper. If we had the whole class, I'd have everyone do this twice, but and actually have dice out. But that's okay. We're going to do this quickly by going in, and we're going to go reset. We're going to 1, 2, 3. All right, we got 2 winners. So we had a 5, a 2. 1, 2, 3. We had 4. Again, we're doing this 30 times. Okay, got 6 here. Okay. Got 6 again. Again, I want to do this about maybe 20 times. Maybe that'll be good. Probably more. The more the better, because again, our sample size is the big thing. By the way, what is this? As we're going through this here, and again, I'm just recording the amount of times out of 30 that we won. If I was to record this, this is called a sampling distribution. Again, the number of ones is the winner, by the way. 2 through 6 are losers, so just a heads up there. Well, 10, that's good. So 8. As we look at this here, this is called a sampling distribution because we're taking a sample of a sample. Each of these rolls of 30 has 30 different rolls in each, but this is a sample of a sample, and you'll see why here in a second. Okay, 12. And let's see what we've got here. 8. See if we can go 2 more. And then we'll pull these in, and that way we could kind of use a little inference to see where we are at. Let's see here. Three. 4. And the other question is this program random? That's probably another good question. And we're going to take a look at this, and maybe we could see. So I'm going to take this data now, and we're going to come back to boom, boom. All right, perfect. Okay, so right now we would repeat this. If we were in class, we'd repeat it X number of times. Now, here's what I'd like to do. I want to plot this. And I think I can do this here. Okay, so this is the on the board. Okay, so we're going to put it right here, and that way you can kind of check this out. Okay, so here's what we have. Again, what context on the bottom. This is the number of wins in AP Stats out of 30, okay? Out of 30. Okay, so as we go here, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did I have any more? Oh, we did have 112. Wow, we did have 112. Okay, so as we go from here, I'm going to do in red the number of times that we had gotten a win in each category. So none at 1, 1 at 2, 1, 2, 2 at 3. All right, 1, 2, 3, 4, 5, 2, 3. I want to make sure I space it out so you can kind of compare it. Let's see, out of 5, there are no, oh, there was 1 5, my fault. 6, 3, 4, 5, 6, 7, 7 of these. 2, 3, 4, 5, 6, 7. All right, let's look at 7 here. 1, 2, 3. 1, 2, 3. Again, this is our dot plot from all of the points that were there that we took. So the sampling distribution. When we took the samples of the sample, again, each dot, what does that correspond to? No 9s, by the way. 110. Each dot represents a sample of size 30 that was conducted in the amount of wins that were there. So the number of wins in AP stats out of 30, probably should go further on the context, out of 30 individuals that won the game or won the contest or whatever. Okay, so 3, 6, 9, 12, 15, 16, 17, 18, 19, 20. 25 total. So in total, there are 25 samples of a samples, which produces a sampling distribution. So the question that we have here is, based upon this information, which is number 7, what % of the time did Coach Jay's class get 2 or fewer prizes just by chance? So we come over here and we say, okay, out of 2 or fewer would be 1 in 25. This was pure, by the way, this was purely by chance. As long as the program was purely by chance, right? We weren't sure, we weren't really 100% sure on that. We could always do this by using real dice. But this would be 4%, and therefore greater than would be 96%. So what % of the time did Coach Jay's statistics class gets 2 or fewer prizes just by chance? We would say that this would be 4%. Now, if you remember inference, you're starting to remember where we're going with this, because in number 8, we then ask the question. Here we go. Does it seem plausible that the company, does it seem, by the way, up here, 2 or fewer is what we're looking for. So any dots that are 2 or fewer, so 2 wins, 1 win, or 0 wins would be what we would look at, by the way. So as we look at this, we're looking for this over here, right? Anything that is 2 or less than 2 to see, is there enough evidence? Does this provide evidence to counter the claim of the company? Okay. Well, as we look at it, the question is are we just unlucky, or is the company telling a lie? Okay. So do we have convincing evidence that they are telling a lie? So we would say that if it is below 5%, we would say that it is statistically significant. Okay. Significant. All right. If it is above 5%, is below 5% or equal to. So below or equal to, equal to 5%. If it's above 5%, we say we do not have convincing evidence. Okay. So it's not statistically significant, which would mean that we do not have no convincing evidence. All right, so watch this. How do we write this? What does this look like? Well, now I want you to really bear down here, because this is where we're going to go with this, okay? So we assuming the Sprite, Pepsi, whatever, assuming Pepsi's claim is true, there is a 4% chance of 2 winners in a class size of 30 purely by chance. That's the next thing. Purely by chance. As a result, this does provide convincing evidence, because it's less than 5, right? So assuming Pepsi claim is true, there's a 4%. This is a result. This does provide convincing evidence that Pepsi's claim is not true. So this does, and this you see it, this does provide convincing against the sodas company's claim, and we would say the claim is not true, stating I don't like that stating, maybe, and is statistically significant. You could have said this in a different way. If you look at the white box down below, you'll notice that this actually is the counter of that. Let's say it was greater than 5%. We'd assume the soda company claim is true. There is, let's say it was 7% probability of getting 2 or less winners out of 30 purely by chance. This does not provide convincing evidence against the soda company's claim and is not statistically significant. And this, they have this in parentheses because 7% is greater than 5%. This next part down below, do not have to do down below here, okay? You do not have to do that down below. Just simply what you state up there because it is less than 5%. So it is statistically significant. If it was greater than 5%, we can't say that their claim is true. We just say we don't have convincing evidence to say that their claim is false or that they're telling a lie. Okay? In this case, we actually could. And maybe there's a lawsuit on hand, which is definitely something that could be used in a court of law. All right, let's talk about a simulation. A simulation is an imitation of chance behavior that accurately reflects the situation, that accurately reflects the situation. My daughter's here. I'll show you her in a second. We're almost done here. I love it. What's up, baby? An example of this would be dice. Your shoes are awesome. Coin flips or random number generator. That's something that you could use, a dice, a coin flip, or a random number generator. All right, last thing, the simulation process, and then we're done. The simulation process, couple things with that. Number one, we describe how chance device imitates situations. So we describe how chance device, which is what, this is right over here, right? What we just did here. How chance device imitates the situation. Cool. All right, that's number one. Number two, all right, just going through these quick. Record results many times. We just did it, right? Record many times. Say record what? Remember, record the results. Okay, record the results. Number three is use results to answer questions. Use results to answer the question. Okay. So what we did was we showed what is a simulation. How do we utilize a situation? Just like in this, the claim of Sprite, Pepsi, or whatever was 1 in 6. So we wanted to make sure that we were utilizing something that represented the same probability in which they stated. 1 in 6. We wouldn't use a coin flip, right? Because that probability wouldn't match up to the 1 in 6 probability here. All right, pause this real quick. If you want to practice, see if you could do your check your understanding. Go through this, just models it for you. And pause, and in 5, 4, 3, 2, 1, I will put down the answer. So in 5, 4, 3, 2, and 1. I love this one because of the basketball shooter here. And we'll go to the next one, and here are the answers. So check them out. If you have some questions, come on in early, and we'll go from there. But you are done with your notes. Remember that as we go backwards, that if you are desiring to get ahead, the homework will be due on Tuesday after learning excursions. And just as a heads up, make sure you take great notes. Do the homework. This is due Tuesday after learning excursions. Check your understanding is a good thing. Read. And, oh, yeah, Tuesday by midnight goes to the homework, okay? All right, hey, before I head out, I've got a little girl I want to show you. Do you want to show your shoes? Come here. Come here. All right, I got this here for you. Come here, baby. See if we'll stop it right after we're done. Come here. You want to show your shoes? All right, so this is Emmy. She's growing up. You want to show your shoes? Show them. Show them on there. Oh, look at those shoes. I love you. Hey, can you say have fun on your learning excursion? Have a great day. We'll see you all on Monday. Bye. I meant to push stop. I'm sorry.